You've probably already learned in class that function notation is a way of naming a function. So I have this relationship, I have this expression, x over x plus 1, or 2x minus 9, or x squared minus 5x. And what function notation does is it does two things. First, it names the function so that I can refer to maybe multiple different functions at the same time. Because otherwise I'd say y equals x over x plus 1, and then y equals 2x plus 9, and then y equals x squared minus 5x. And it's hard to know if I'm talking about y, which one I'm talking about. So by calling this f of x, this one g of x, and this one h of x, now I know that if I'm talking about function f, it's that one. When I'm talking about function h, it's that one. The other nice thing is that it gives away, it shows the input variable. It shows what is being plugged in to that function. So in this case, in the general description, in the general function notation, we're just saying that it's x, that x is that input variable. But if I was to say something like f of 5.2, then that means that I'm taking that 5.2 and I'm plugging it in where the x's are. So I would have 5.2 and 5.2, but otherwise everything else would be exactly the same. I have 5.2 over 5.2 plus 1, which of course is 5.2 divided by 6.2. And if you do that in your calculator, it works out to be something like 0.8387. And so f of 5.2 is approximately equal to 0.8387. What we're doing is we're taking that 5.2 and we're replacing everywhere we see an x with the 5.2. This is, again, what you probably have done in class already. Now, what is a little bit different is the fact that we can actually do this for not just numbers. I can replace x with a completely different expression. I'll give you an example. G here. Let's say I want to plug in g of x minus 1 instead of g of just plain old x. I'm just going to do the same thing like I said before. I'm going to replace the x with an x minus 1. But you got to be careful. Don't just do 2x minus 1 minus 9. Because then that would give you 2x minus 10. This is wrong. This is incorrect. The problem here is that this x minus 1, we're replacing x with that. So if I'm saying I have 2 times x before, now I'm saying I have 2 times x minus 1. That whole thing. We need to put that into parentheses. Whenever you replace, and I recommend writing this down in your notes, whenever you replace something using function notation, whenever you plug in something, plug it in with parentheses. When plugging in with using function notation, use parentheses. Because that way you won't make these mistakes. This is actually, we would distribute the two, we would get 2x minus 2 minus 9, giving me a final value of 2x minus 10. So 2x minus 10, sorry, minus 11, not minus 10. 2x minus 11 is my final answer. So replace with parentheses. This is especially important when we have a negative in the parentheses, which is the last example on your notes there. When we're replacing, when we're using function notation, we always replace with negative, or with parentheses. So if down here I want to do h of negative 4n, I'm going to plug it in with parentheses. I'm going to say that that's equal to negative 4n squared, the square of negative 4n, minus 5 times negative 4n. And if I'm squaring negative 4n, I'm saying negative 4n times negative 4n, negative 4n times negative 4n, negative 4 times negative 4 is positive 16, n times n is n squared, and then I have negative 5 times negative 4n is positive 20n. And so that's what h of negative 4n is equal to, 16n squared plus 20n. So again, when you're plugging in something using function notation, when you're using your function notation to show what is being plugged into that function, make sure that you plug it in with parentheses. Otherwise, you might screw up a negative. You might have thought that that was a negative 16n squared or something. So just be careful about that.